Hello everyone. Today we'll talk about Wye-Delta starting of a three-phase induction motor. Okay. Before we go over the circuit, we will explain the purpose of this technique. Actually, this technique is because of the starting current. We have an issue of the starting current. The starting current is high in the beginning, and this is one of the issues that we face. So because of that, we will use this technique, which is using. Let me just fix this here. This is R, and this is R, and this is also R. Okay. This technique, guys, is using, instead of using delta immediately, we will use Y. Why we do that? We let the motor works with Y for a certain time at the beginning, and then flips to delta. Okay? Why is that? The reason is, let's read this fast. Wye-Delta starter reduces the starting current. That's the purpose. By connecting the motor winding in Y. So we will start with Y, which is this connection here. At the time of starting, this reduces the voltage across the winding, where it will be 1 over square root of 3 times V line to line. Let me explain this another way, which is if I have a delta, and then I have line 1, line 2, and line 3. If I have 120 here, 120 here, and 120 here, what will be the voltage in the phase? It will be the same. We know that here V line to line, same as V line phase. So here it will be 120, here it will be 120, here it will be 120. So if we start with delta, we will have high voltage, which is the same as the source. And if we come to Ohm's law, I equals voltage over resistance. If the voltage is 120, and the resistance, which is the armature resistance, is very small before the motor starts. So dividing 120 divided by very small amount of resistance, the amount of current is huge. We call this starting current. We don't like this. So what we will do right here, instead of using this connection right here, we will using Y connection. So line 1, line 2, and line 3, and it will be, the source will be 120, 120, and 120 between this and this. So what will be the voltage in the phase? The voltage in the phase will be this. The voltage in the phase will be V phase equals V line to line divided by square root of 3. We know this from machines. So it will be the V line, which is 120. V phase equals 120 divided by square root of 3. It will be around 70 volt. So we bring the volt down. If we bring the volt down, means the current will, so the volt, instead of 120, now it will be 70 divided by a small amount of resistance, so the current will be down, will be less. So with this technique, we save or we protect the machine. Okay, so what will happen here? We will, this is S, and S stands for start. So we will start the motor for a certain time, and then we will switch to R, which stands for run. Start and then run. Okay? Let's see what will happen here. Okay, I'm going to use those colors right here. Now, this is the source, 120. This is the control circuit. We notice that there is no transformer in this circuit because the source is 120. So the source 120 means that's 120, and we don't need to go down because we know the control circuit works with 120 volt. Before we used to connect 208, so we bring 208 to 120, and now we don't need to use a transformer because the source initially is 120. So what will happen here? Let's press start. So this is the start here. We press the start, so the current will pass through the switch. And then the motor will, the contactor will be energized, okay? When this is energized, it will close the normally open, close the normally open, close the normally open. So which one will start? Actually, guys, this one here is normally open also, initially normally open. So when this is closed, the motor will run with the Y connection, because as we explained there, we want the current to be very small, very tiny. While we do this, this time relay is parallel to this contactor, so it will be energized also. So this will be energized. This will be energized. So when this is energized, immediately it will close this, because this T instant is with the time relay. So now you can release your finger. So the current now will pass. We open a path for it here. Okay, so the motor is running. We have here now the SR contactor. SR contactor of, is a contactor of some contactors which is normally open and normally closed and normally open. The normally closed will be used for the start process, and the normally open will be used for the run process. Now this is timed, the time relay. Let's say it's timed for 5 seconds. Okay, so 1, 2. After we press 1, 2, 3, 4, 5. Now when the timer, after the time, the TDC will be closed. So this will be closed. And the TDO will be open. So this will be open here. Time delay open. So when this is open, of course, this is closed and this will be energized. Or actually, let's say that when this is, when the time starts, which is the 5 seconds, this will close and this will be energized, which is the start run contactor, and this will be closed. So this one was closed before, and now when this is energized, or after the time, actually after the time, which is the 5 seconds, this will open. But now we already close this and energize this. So when this is energized, this will close. So we open a path for the current. So the contactor stays energized. So this one closed. We don't want the motor to stop. So now here, when this is energized, the SR contactor is energized. It will open the normally closed. So this will be open, and this will be closed. So now we switch from Y connection, which is this, to Delta connection, which is this. Because we don't want to stay working with Y connection all the time. We want only at the starting of the process to use Y. Otherwise, we want high voltage. We want 120 volt. Because if we just stay with Y, the voltage is low, and the output is what is not the one we are looking for. That's the Wye-Delta starting of 3-phase induction motor. So the key point is here. The key point is this: that the armature resistance is very small, and in this case the starting current is huge, and we don't like this. We don't like the starting current to be huge because it can harm the device. So we work with the voltage instead of working with the high voltage. We work with Y because the phase voltage in the Y is less, and we bring the voltage down. We divide it by small resistance. We bring the I starting current, or the starting current, down. After that, what will happen to the resistance after the motor runs? The armature resistance will pick up and will increase because of the back EMF. So when it increases, this one after the motor runs, the armature resistance will increase because of the back EMF. In this case, even if you go back to the high volt, which is 120, which is the delta, no problem, because the resistance is high now. So with this, we solve the issue. And here, so the voltage is huge, that's we explained, then the current will be huge. So to fix this issue, start with Y, then go back to delta. Okay? This is our experiment for Wye-Delta starting of a 3-phase induction motor. Thank you.